In this video, we're going to be talking about how to determine the type of transformation of a cubic function. So in front of us here we have f of x equals the negative a raised to the third power times the square root of negative m times x minus h plus k. So we're talking about what each piece and what that means for the transformation. So let's first take a quick second and decide, how's a square root different than a cube root? Well, let's look at the graphs to help us out with that. A square root function might start in an h comma k spot or a place and just have one motion, one arc up or one arc down. We call this our starting point, and then this is kind of like a whoop as it moves. Now a cube root, on the other hand, is going to have this kind of inflection point here. It is constantly increasing the whole time, but notice that we kind of have two tails now, as opposed to having one point and an arrow that keeps going, like a ray, similar but not the same. And now we have something similar to a line, but not quite, because it's not straight. So for lack of a better word, we're going to call this point right now a starting point, and then we'll go up and then down from that same spot. So our graph's going to look a little bit different. It's almost like a really long S that somebody took and they stretched it out, right? So it looked more like that. So it's a really long S there. So let's come over here back to our equation and decide how this can help us. All right, so first, the H. The H deals with the horizontal translation, so it either shifts things left or right. Now notice that we see a minus with the H right now. And when we see a minus in our problem, we actually are going to move to the right 2 places there. But when we see a plus, we're going to move to the left. So when things are on the inside, they're kind of do the opposite of what you think that they should. Let's move on to our K. Our K is not on the inside of the root with the H or the X. It's out on the outside by itself. Now here, if we see a plus, it is in fact going to go up. And if we see a minus, it is in fact going to go down. So our K controls our vertical shifts up and down. The negative sign that we see in the front of our A and in front of the M represents our reflections, and depending on where the negative is depends on what type of a reflection that is. So for example, if we have a negative on the inside with the X, this is going to be a reflection across the y-axis. And if we see a negative on the outside of the radical or the cube root of x, that's going to give us a reflection across the x-axis. So what about our M? Well, that's going to dictate our horizontal stretches and shrinks. So how far away it moves from the y-axis, or how close it moves towards the y-axis. Now it's on the inside, which means it's going to do the opposite of what we think it should do. So on this first one, for example, we have the cube root of 3x. So we think this is probably going to be some kind of a stretch, but it's not. This is going to be a horizontal shrink by 1/3. Which means that the next example we have the cubed root of 1/2 x would be a horizontal stretch by 2. The A on the very front of our function here dictates our vertical stretches and shrinks, which is the distance either away or towards the x-axis that we are on our graph. So in this first example, we have 4 times the cubed root of x. And so this is going to be our vertical stretch by 4. And a 1/5 times the cube root of x will be a vertical shrink by 1/5. Let's go ahead and do a few examples really quick for some practice. So for each of these functions, we're going to do 3 things. We're going to describe the transformation from the parent function, the cube root of x. Then we're going to sketch the parent function and the given function, and then identify that starting point. So in the first example, we have g of x equals the cube root of x plus 3. So let's go ahead and let's graph. All right, so we'll pull up our y equals, and we'll put in our cubed root of x. So we're going to go to math and go down to our cubed root. So the cubed root of x, that'll be our parent function. Let's just take a look at what that looks like. There we go. And now for our new function. So our new function is the cube root of x plus 3. So math, the cube root of x, an arrow out, plus 3. So how do we see that changed? Well, it looks like it went up 3 units to a new starting spot of 0, 3. So let's go ahead and write that down, that we're saying that this went up 3. All right, and so we're going to go ahead and say that that went up 3, and now we're ready to sketch that. So remember that this is what it looks like, so we're going to go ahead and sketch that now. There we go. And then our starting point. So I'm just going to put SP for short. So we had an H value of 0, see how there's no H in there, and a K value of 3. So we have a H comma K, or a starting point of 0, 3. So let's go ahead and write that down. Starting point of our H, comma, our K value. So that's kind of a nice little like shortcut to get that. Let's take a look at this next example. Here we have g of x equals 2 plus the cubed root of negative x. So here we have the 2 in the k spot, although it's in the front, but it's being added on the outside. And then we have that negative on the inside. So the 2 in the front tells us that we're going to be moving up 2. And the negative on the inside tells us we're going to be reflecting. And we use the chart we just looked at. That should be the y-axis. We're reflecting across the y-axis. So let's go ahead and let's plug that into our calculator. So we'll keep our parent function, and we'll change this next one to 2 plus the cubed root of negative x, and we'll graph that. Kind of makes a weird looking x, kind of. So let's go ahead and let's sketch that. And we see that our starting point for this one, it's moved, instead of at 0, 0, it's moved up 2 places. So our starting point here is going to be at 0, 2. Let's look at a couple more. Let's have you do these two on your own. So go ahead and push pause, work them out. When you're done, push play, and let's see if you were right. So in this example, we see that we can move to the right 4. And we don't have to graph this to see our starting point, because our H is a 4 and our K is a 0. So we know our starting point is going to be at 4, 0. And when we graph this, we see that it's moved to the right 4 spots. It's nice and long. So let's go ahead and sketch that. And that should be what your answer looks like. Now number 4, here we have that plus 5 in the K spot. So we're going to be moving up 5. And using our H and K for our starting points, we have a starting point of 0, 5. So then we go ahead and we graph that. And that's going to give us a graph that looks kind of like that. Notice how that's moved up 5 spots. But it looks exactly the same, just up 5. So we can go ahead and we can sketch that. Let's go ahead and do 2 more that are a little bit more complex. So here we have f of x equals the cubed root of 1/2 x plus 2. So that 1/2 in the front tells us that we're going to be having a horizontal stretch by 2. And then our plus 2 on the outside is our k, so we're going to be moving up 2. So we don't have an h value, but we do have a k value. So our starting point should be at 0, 2. And if we graph this, we see that in fact our graph does move up 2. We're at 0, 2, and it kind of looks a little flatter than our original parent function graph. So let's go ahead and let's sketch that. Let's move on over to number 6. So here we have 4 times the cube root of x plus 3 minus 1. So the 4 out in the front tells us that we're going to be having a vertical stretch by 4. Our h, we have a plus there. So we know that means we're going to go to the left 3 spots. And then our minus 1 on the back is going to go, that's right, it's going to go down 1. Now here we have an h and we have a k, which means our starting point is going to be at negative 3, 1. Because remember, that's supposed to be a minus inside of there, but it's been changed to a plus. So that means that we must have a negative as our h. So what does that look like graphed? Well, if we plug that into our graphing calculator, we see that, wow, we have this great big jump that's happening. Let's go ahead and sketch that. And there we go. And so that's how you can determine the type of transformations of a cubic or cube root function.